Now, this was the real reason that the Titanic sank in water. When there is a storm in the sea, many forces on the ship affect the ship. If the ship starts tilting to the left, then water is pumped on the right side in these tanks so that the ship cannot reverse, and the balance is done. Before the construction of a big ship, a small model ship of the same kind is made, so that after testing it like a real ship, the construction of a big ship starts. Imagine you are on a cruise ship and suddenly you got to see this from the window of your cabin, or you see this view from the top floor, or if something like this happens to you, then maybe you start thinking you will go that brother. Now, it is difficult to survive, but guess what? Today's cruise ships can keep you absolutely safe in worse conditions. So what is the secret that these ships can withstand strong winds and storms like mountains? The biggest thing is the buoyancy principle. That is, when an object is in water, according to the weight of that water, a force is applied on it from bottom to top, which is called buoyant force. At the same time, according to the weight of that object, the force of gravity also applies on it. If the buoyant force is greater than gravity, then the object will not sink in water. Throw a stone in the water, throw a stone in the air, which stone will go down quickly, which is thrown in the air. Because there is only gravitational force, there is no visible force, the stone that is thrown in the water. If there is also a buoyant force, then the stone will go down slow in the water. It will slow down in the water because now there is resistance due to the buoyant force. Now the ships are of thousands of tons. Why do they not sink? Because the ship is hollow from inside, which is called buoyancy reserve. If the total density of the ship is more than the density of the water on which the ship is on, then the ship will not sink in water, but the more the density of the ship decreases, the more that water. Now, this was the real reason that the Titanic sank in water. As soon as the water went into the hull of the ship, the density of the ship started decreasing and the Titanic sank. Stability of the ship. More things play their role for the stability and balance of the ship, such as the center of gravity and the center of buoyancy. Center of gravity is the point where all the weight of the ship is, and the center of buoyancy is the point where the maximum buoyant force is taken. If these 2 points are in one place, the ship cannot reverse. When there is a storm in the sea, many forces on the ship affect the ship of the mill. These forces are called moments. Strong winds, waves, currents and cargo move. Due to all this, moments force is formed. If they are not balanced, to avoid this, the ship should have a stability system. The stability system is the job. Whenever the shadid moment forces come, the ship has to be kept stable. For stability, the center of gravity and the center of buoyancy have to be managed. If the ship tilts due to waves, then the center of buoyancy will change. Similarly, if the center of gravity changes due to cargo or passengers, then there can be an issue in the ship. If the difference between these two increases, then the ship goes into the unstable state. To avoid the unstable state, the solution of the ship is made very carefully, which controls this matter to a great extent. In keeping safe, mess means how to divide whatever cargo or passengers are present on the ship so that the center of gravity is balanced. So whatever activities you see on the ship, cabin chairs, all such things are installed. This is the reason behind them. Next is the ballast system. Extra weights added to the ship's bottom to keep the center of gravity low. Ballast tanks are large containers that can hold water, sand, stones or metal. Ballast is crucial for stabilizing the ship. Stabilizers. Now comes the turn of stabilizers, which are some devices and they are installed in the hull of the ship so that the ship can be prevented from tilting on any side due to waves and winds. Stabilizers sometimes use fins which can be moved up and down, or tanks are used in which water is pumped. If the ship starts tilting to the left, then in these tanks, water is pumped on the right side so that the ship cannot reverse, and balances the speed of the ship matters a lot in the safety of the ship. The faster a ship is, the more hydrodynamic forces will be produced, which can make the ship unstable. In high speed, there is a change of muscle water pressure around the ship. In view of this thing, the ship is designed in such a way that the ships are saved from sinking in bad conditions, but still, no ship can be 100% safe. Some things are unpredictable, such as weather, currents, ice, and collisions, so designing the ship is the most difficult and complex task. Without doing a lot of testing on the initial stages, the ship cannot go into the water. Ship testing is more important than the limit. Before the construction of a large ship, a small model ship of the same kind is made, so that after testing it like a real ship, the construction of a big ship starts. Hydrostatic calculations are done before making ship models. A precision ship model in which there is no mistake is thought of building a ship. Due to high-level computing technology, today it is possible that now a perfect ship model can be made, and in view of this model, a real ship is made. Many ship models are tested in all kinds of small water tanks in an experimental tank facility. These models are well tested, which are also called tow tanks. Sometimes these tanks are 100 meters long and several meters wide. By testing in these tanks, large ships can successfully run in water. Platform moves, the ship moves from which data is collected. Even researchers can sit in this model themselves and see everything with their eyes. The model ship is also tested in wave tanks. This test simulation is more realistic because there is a proper testing environment like the atmosphere of the sea. Physically, the wave tank looks like a towing tank, but the length is more and the depth is also the best feature of the wave tank is the trench present in its very center. There are many technical reasons behind making this trench. The main idea is to create a sea environment in which there are different depths. All types of waves are made with the help of wave generators in the wave tank. Now the question is, how are these waves created? It's simple. Air pressure variations are applied underwater using special machinery. A mechanical system creates hydraulic forces that an electric motor powers this wave maker. Data is collected by testing ship models at various speeds and resistance levels. This data informs decisions about large ship design.